The International Space Station will start its gradual ascent from orbit sometime in the following 10 years. The gigantic structure gradually descends from its 400 kilometers of height, entering ever thinner layers of our atmosphere until it approaches a point of no return, 280 kilometers over our heads. From this point, air resistance will cause the unit to slow down quickly and start to disintegrate. The point of the Earth that is furthest from any continent, Point Nemo, is expected to disintegrate over a planned debris field, the uninhabited region of the South Pacific Ocean. After more than 2 decades of invaluable service to humanity, the ISS will rest here, in Earth's aquatic spaceship cemetery. But all of this raises a concern. Why? Why would such an important piece of space hardware be decommissioned? Welcome, and you are watching Technology Zone, where the home of technology resides. Join us as we unveil the answer to this question here in this video. Ever since the first ISS components entered space, the station has gradually expanded. The first module of the ISS, the Zarya cargo module, was launched from Kazakhstan on a Russian Proton launcher on November 20, 1998. Zarya served as the beginning of everything. With it came the docking, propulsion, electrical, and guiding systems required to steadily expand what would eventually become a remarkable feature of global space infrastructure. Just 2 weeks later, the Unity module joined Zarya. A module has 4 radial connection points surrounding its perimeter and 2 axial connection points, one on each end of the module, where the initial truss pieces would be fastened, enabling the deployment of enormous solar arrays and the supply of electricity for the developing space laboratory. These parts of the International Station are still in orbit today, meeting the demands of more than 250 different astronauts who have been in Earth orbit for the past 23 years. But because it was never meant to be a permanent residence, many of its parts are beginning to wear out. The Zarya module, which served as the foundation for the whole space station, has acquired a number of breaches that will continue to spread. These modules gradually deteriorated over time as a result of cyclical thermal expansion, which is brought on by the 16 sunrises and sunsets the ISS observes every day. At the same time, the structure might be stressed by the jolts caused by the spacecraft landing with the space station. Not to mention the continuous barrage of space debris and micrometeorites that have harmed crucial ISS components, such as the hit on the Canadarm in 2021. As the station matures, problems like this have started occurring more regularly. Mysterious pressure breaches have even sent astronauts on fruitless searches for the cause of their atmosphere slowly venting to space. The core construction of the ISS, which consists of these modules, is what will ultimately shorten the station's lifespan. It is only a matter of time before the modules need to be removed. While the Canadian, European, North American, and Japanese space agencies have carried out these inspections through 2028, skeptically, Russia, who seems to have become an international pariah, has only finished these inspections through 2024. Also, every participating team of the ISS is expected to examine and conduct life-extending maintenance, reducing the present lifespan of the ISS to just 2 years. The International Space Station was never intended to have significant portions of its construction removed to enable a contributing team to stop cooperating. Thus, the war in Ukraine has put NASA's recent transition and decommissioning study, which planned to deorbit the ISS by 2031, into doubt. The International Space Station may only be operational for another 2 years without Russia, which may spell disaster for NASA's long-term goals outlined in the transition assessment. Let's take a closer look at the decommissioning and transitioning reports to learn what we might have just lost. With good cause, NASA has been preparing for this decommissioning for a while, as shown in the visualization of the report's turning pages. Every year, the International Space Station charges NASA about $3 billion, with the price of getting people and supplies into space and the price of running the station's systems and maintaining it being shared equally. In order to put that amount into context, $3 billion is more than 10% of NASA's overall $24 billion expenditure and more than 33% of their budget for human space travel. The Perseverance rover mission pays a whopping $2.7 billion, which helps put problems into context. The actual reason that ISS would be shut down is because of these expenses. The transition study outlines a strategy for dismantling the International Space Station in order to free up close to $1.8 billion annually for NASA's plans for a lunar colony. Although it in and of itself is thrilling, Is it really worth giving up the International Space Station in the process? Fortunately, the transition plan outlines how NASA will continue operating in orbit while freeing up $1.8 billion from its annual budget. The last 10 years have seen a significant transformation of the space sector due to commercial spaceflight. The Falcon 9 seems to be the only American launcher completely approved for carrying people to the International Space Station. And given the present situation with the crisis in Ukraine, NASA would not be able to deploy astronauts there without SpaceX. This commercial space sector development will let NASA keep an orbital foothold while conserving money to support a new rover every 18 months. Offloading the creation and upkeep of the upcoming generation of orbiting space habitats to the commercial space sector will save the majority of this expenditure. This is something NASA has long wished to achieve, and SpaceX performance makes the advantages obvious. Its pricing and innovation prompted the whole industry to change. The commercial space sector must have something to offer in order to thrive in low Earth orbit despite the competitive nature of the commercial sector. And here, a healthy economy is necessary. Several of these businesses were included in the ISS transition plans. NASA identified a few essential industries that may thrive in space, and NASA also performed research to identify the most profitable businesses that could locate their home over the next generation space station. The entertainment industry is the first. Consider a setting in which the war room for Ender's Game is actual. Space Entertainment Enterprises is working to make that future into reality. They want to shoot an untitled movie with Tom Cruise as the principal actor in their spherical inflatable movie studio. But this wouldn't be a one-time event. Anybody with a sizable sufficient budget could rent the studio, couldn't they? NASA granted Axiom Space a $140 million agreement in 2020 to launch a module that could connect to the International Space Station in 2024, allowing for the housing of corporate astronauts and the continuation of scientific investigation. The Axiom Space Station would be able to function totally autonomously from the ISS and cultivate the other sectors that NASA recognized as potentially lucrative space economies if this initial phase of a planned extension of a private part of the International Station is successful. This strategy includes the Space Entertainment Enterprises module. Also, even manufacturing for microgravity was another sector mentioned. There are several significant benefits to manufacturing without the impact of gravity, but they must be realized before the expense of launching raw materials into space can be supported. Manufacturing operations are impacted by gravity-driven processes such as sedimentation, convection, and hydrostatic pressure, which are eradicated. For instance, sedimentation makes it more challenging to combine a liquid uniformly because dense particles settle at the bottom. Let's say that we are making an alloyed metal with constituents of complex and difficult density. There are a lot of opportunities to develop new, higher quality superalloys in space, since these non-uniformities can have an impact on the material characteristics of the final metal component. This is only one of several manufacturing methods that may be used in space. According to the current transition strategy, this Axiom commercial space station will separate from ISS in 2028, serving as a new foundation wherein the space station can keep growing and serve as a workspace for future NASA astronauts, with rental payments going to Axiom and transportation costs going to SpaceX. There are many positive aspects to the proposal, but what are the possibilities that it will be implemented given that it seems to be impossible to cooperate with them because of Russia's invasion of Ukraine? For power, Russia's segments depend on America's segments, while America's features depend on Russian propulsion to maintain the orbit and to avoid space junk. Additionally, international collaboration is necessary for the operation of this global space station. Judging on their recent uniform modification, Russian astronauts are evidently opposed to the conflict in Ukraine, although they are not in charge of this situation. The truth is that if this keeps up, NASA will have to make some crucial choices in the following 2 years. Here, several results are possible. One of these is not the Russians dividing their modules. Since they depend on the rest of the ISS for electricity, they would struggle to finish the task without the assistance of the Canadian robotic hand. In the following 2 years, Russia may, by certain miracle, get its act together, toppling Putin's government while maintaining international collaboration in space. Alternatively, Russia's segments could not be approved until 2028, requiring an earlier deorbiting of the International Space Station and abandoning plans to convert it into a commercial space station. Conversely, NASA might be given emergency funding to provide the ISS with extra modules quickly to substitute Russian operations, such as propulsion for orbit maintenance and debris prevention, permitting the transition preparations to go as scheduled. Alternatively, the money may be given directly to commercial space firms to advance changeover preparations, but it would be a huge request of unproven providers in a 2-year time period. Only one thing is certain: the ISS present organization is temporary. Its basic structure is getting older every year, and eventually, over the next 10 years, it will be deorbited. The only remaining uncertainty is when. The International Space Station has only been in orbit for a little over 20 years, which is difficult to comprehend. At the forefront of scientific investigation, it has served as a significant source of hope for ambitious scientists and engineers all around the world. Fewer than 253 astronauts from 19 different nations have ever had the opportunity to go and operate from the International Space Station, making it widely regarded as the pinnacle of scientific professional achievement, a delight that very few of us can ever know. Fortunately, Brilliant offers us a small amount of the thrill of scientific study. I became interested in engineering because of the dopamine high you get when you find out an issue you had been attempting to solve. But anyways, watch our most recent video on our channel if you're searching for something else to watch today. Also, subscribe to our channel Technology Zone, give this video a thumbs up, and ring that notification bell to always be up to our latest videos because we assure you, you'll never regret watching them.